Hi, I'm Scott Chacon. I happen to be a certified wine expert, and today on Bits and Booze, I'm dropping off a package for the 20th birthday of Git, but not here.
Welcome to this episode of Bits and Booze. I am joined with my co-founder at Gitbrother, Kiril, who will be, I think, doing something really fun, which is going through the very, very first Git commit and seeing what, in the first commit 20 years ago, what could it do? As is mentioned by the title, it's Bits and Booze, so we need to start with the booze. So let's get some drinking on.
Let's get something.
You went in and chose a random bottle? Or
No,
did somebody else?
It's Caleb's chose.
Caleb chose a bottle. I don't know what it is. Something Spanish? Oh no, it says product of Spain right there in English. So it does look nice. It does look nice. It has some pictures of stamps on it. It is a Vino Tinto.
What is Tinto?
It means it did something in its past and now it has a criminal record. You ready?
Yep.
I actually don't even know what grape this is. It looks a little brown, actually. It looks a little aged. I don't know if you can see that color on this.
Looks like red wine.
Cheers. Cheers to the first Git commit. It does taste older, right?
This is my kind of wine. I don't drink wine a lot, but this is my kind of
You like
wine.
that?
It's like not very sweet, not.
Yeah, it's a little bitey, it's a little acidic, but it's a nice one. Okay,
Yeah,
so we have a nice Spanish red wine, and we're ready to get into the topic of the day. OG Git.
the OG.
I pitched this to you,
Ah,
and I was like, I'm gonna walk you through the first Git commit, and you went and got it to work on your machine.
I could not wait.
You compiled it, you started messing with shit. You know more about the first Git commit now than I do. So the very first Git commit, yeah, actually, can you tell me the date? You've looked at this already?
It's April 7th, 2005. Just a wild guess.
You're right. It's
I'm just guessing.
so the first Git commit, or the first commit to the Git project by Linus was in April of 2005. It is now, right now, January of 2025. So we're almost at the 20th anniversary of the Git project, right? And so for the 20th anniversary, let's go back. We're gonna compile the first thing. You're gonna teach me what it could do.
You know, surprisingly a lot. I mean, I was able to get it working on a modern day Git repository. So that was funny. So I guess the disclaimer bit here is we're using a project called BabyGit.
Yeah. So the background of that is that Git doesn't really compile cleanly 20 years later on modern GCC, right? On modern like OpenSSL and zlib. There's a couple of libraries that it depends on. It doesn't compile it cleanly. And so there's a guy from Atlassian, Jacob. So Jacob got it to run. I actually tried to get the first one to compile and it didn't. And I saw all the errors and stuff and I was like, oh no. But it turns out that Jacob from Atlassian got it to compile and has a repository that we'll link to as well in this that has just the first commit and then some changes to make it compile modern.
We can show it right here. Like this is the first commit, April 7th, and then a bunch of stuff.
So this is the first commit. It's interesting because differently than how you would normally do this, that SHA, I think, actually matches the same SHA. So if you go to like GitHub, git/git/this, right, or however you do the URL for a commit, that SHA is the same because there's no parent, right? So it's not like he rebased something. Like there's no parent, so everything matches. So it is actually the same SHA. So that E83 or whatever, that is the SHA for this the first commit.
Do you have tattooed this?
I have it on my ass. This is super embarrassing. Should I?
Right.
No. So
It's an important SHA.
So it is an important SHA. But what's funny is that this is the commit message, right? Initial version to Git, the information manager from hell. That is still what it is today, I think.
I think it's still.
But let's look at what it was. So again, Jacob and others have added some stuff on top of this to make it compile now, right?
And I had to do an extra bit so that it compiles on my computer.
But make it.
All right.
Lots and lots of bullshit. And now what happens? But it does compile.
I can install it in a special directory for myself. Make install. Right. So I have it now in. If I go to.
Wait, did you do that? Was that one of the makefile changes?
It's one of the. It's actually already here in the home bin.
Okay.
And now I have a bunch of.
Okay, so these are the 7 commands?
7 commands.
So
separate binaries.
This is an interesting thing, right? the first version of Git, it wasn't one binary that had subcommands or something. It was like 7 different binaries. How many are there actually? 7.
7.
So there was 7 different binaries, and they didn't even start with Git. In later versions of Git, what these morphed into was like git-cat file and git-commit tree, and it was still 100 binaries, right? And they would put it into like user lib bin or whatever, like I don't know, something that was executed. But like there was so many binaries that Git, and then at some point it changed, and then it was one binary that would run all these subcommands. But the very, very first version was this, right? It was completely just 7 completely random commands.
There's no help or anything of that nature.
Again, this is the first commit. So look at the first commit, anything you've ever done. It's like
way better than anything I've ever done.
It's actually not bad, right?
Yeah.
So let's look into these. Actually, a lot of these are still, let's go through this. A lot of these are still Git commands. So if you run git-cat file, that's still command. Commit tree still command. Read tree still command. Write tree still command, right? So all of those basically all still function if you run git and then that thing.
Should we start with a brand spanking new repository?
Do it!
And we have a good file.
Yeah, it's a really good file. If anybody wants to add to this file, add to that file. dadjokes.md. It's a really good way to do a pull request on a Gitbuilder repository.
Right. So there was. Let's look what we had here. So there is initdb. This is what we need to do.
Right. So this is the modern equivalent would be git init, right? So if you have a project or whatever, you'd run git init, it'd create a .git directory and set up the sort of skeleton for what you would need to actually do something.
Right.
So this version is initdb. So what does it do actually? So let's look at the directory now. There's a new directory in there. It's not .git, right? It's .dircache. What's in .dircache? Slam it down.
It's fairly. I mean, you have the objects folder.
So, but look at the objects because I find this actually pretty funny. Look at the objects.
Yeah.
So right now, if you go into .git/objects, if you go into your Git directory in whatever project, there's usually a couple of, I think, single characters. Now they're doing a single character, but this one they pre-compute every single 2-character sort of hexadecimal thing so that they can start throwing objects in there. So but there's nothing in there. They're just empty directories, all of them. But they pre-do them. So now let's put some stuff in there. So now the next one you want to create an index, right? Like
in Git you'll be adding it to your index, and here we talk about cache. So you're saying update cache.
So this is essentially what git add does now.
Bin.
It takes contents from your working directory, it creates a git object, it updates the index file now. I'm actually really curious. I haven't run this, so I want to see what it does. Like, what is in dircache now?
So I think there is like a index.
All right, index file. So it's already an index file.
Should we try to cat it? I wonder if it's binary.
It is probably binary. I mean, we can hex dump it or something.
Yeah.
No, let's hex dump it.
Wow.
Look at that.
I mean, do you see numbers? Because I can see the content.
I see lots of numbers. Isn't it? What shows a? Okay, it doesn't really matter. Okay. Who gives a shit?
But there is another command. We something diff. If we say show diff, this is gonna tell us.
Okay, so this is interesting. So this is clearly an equivalent of git diff, but I don't know what it operates on. So does it operates between the index and the working directory, or the last commit and the index?
So it appears to be just giving you information about the index. So you see the output. It's kind of weird.
All right, let's do it. Let's run it. Show diff.
Oh, it says okay.
The working directory and the index are the same, and so the output is okay.
Yeah.
Okay. So let's change the file in the working directory. I want to see what it says. I'm learning so much now.
Yeah.
Or edit the file, and then add in. Why did the chicken cross the road?
That's a lot of text. Why did the chicken cross? Why?
To get to the other side.
To get to the other side. Is this supposed to be funny?
I want to see the diff.
Yeah.
All right. So if you think about this, I think from the context of Linus at the time, this is useful because you can get something you can email, right? Like this gives you a diff output that is applicable
Right.
with patch. So you could email this, or you could take it and put it in an email and send it to somebody and say, okay, here's the difference of what I've worked on for a while. So this already becomes kind of a version control system, right? So the lower level stuff is there from day one. So let's see how do you create a commit in Git?
First, we make a tree. So we have to say bin, I think, write tree.
So can you tell me succinctly what this does? I'll tell you what it is.
Okay, tell me what it is.
When you say write tree, it takes the index. It doesn't look at your working directory. It just takes whatever state the index is in, and it writes that tree out as a Git object. And then that can be used to create a commit that references that, right? So it's these three sort of separate things. There's the working directory, there's the index, which is like this middle ground, and then there's a commit, like an actual commit that is referenced by a branch or a head or something like that. And so what this is doing is separating those stages out. So if you say write tree, it's not going to look at your working directory. It's going to look at whatever you updated the cache with, whatever the index looks like. So let's modify dad jokes.
Bim, dad jokes.
And say, why did the chicken cross the road to get to their side? So let's save that. Now that's in the working directory, but you have not updated the cache.
Right.
So the tree you write should be to get to the other side, not to get to their side.
Yes.
Right?
Write the tree. Write the fucking tree. I'm a tree man.
Oh my. Write tree. Okay, so I've written the tree.
You've written the tree.
I have a SHA for this.
You have a SHA.
And now I can say commit tree, and then I give it the tree SHA. And now it expects me to
write a commit message?
Write a commit message, yes.
Oh, shit! I did not know that that's how this works.
Yeah, but
that's amazing.
But now, enter is not what kind of escapes you. You have to type Command D or Control D rather. So now you have a commit.
Okay. What is that useful for in this context? Because there's no log, right? There's no git log at this point.
We can look at the thing we just created.
Yeah.
And the way this first version of Git does it is kind of funny. The way you get the output. So if we do bin the cat file of the commit thing. So what this told us is, hey, this is a commit, and this is where the output is.
It's in a temp file.
It's in a temp file, and if I just list the.
Let's look at the temp. I'm fascinated what this looks like now.
Yeah, this is. This
oh,
actually,
it is. Okay, so it's the commit data.
Yeah, let's do read tree on this.
Normally, what this does, it's like a reset. So read tree is like a reset.
Oh,
so it says make this tree my index. So it resets it to.
I did not know that.
Yeah,
this does something else.
What does it do?
I mean, it's like a ls tree.
Oh.
Yeah. So we can ls trees.
Oh, interesting. Okay.
And
what can you cat file that SHA?
Yes.
Do you still like this wine, or is it not growing on you?
I do like it. It's a blob, and what throws me off is I expect output.
Yeah, but you have to cat the file.
Yeah. Now I have a file to cat. So.
That's interesting. Okay, so you do cat file and it writes the output to a temp file.
Yeah.
And then instead of printing it.
Yeah. So you have.
But that is the content.
Yeah. You have.
What is actually at the top of this? It is the content that we run update cache on and wrote the tree, committed the tree. Now that's the commit. Right. Can we do one more commit that changes this?
Right.
And do a commit with a parent.
Yes.
And just see what that commit looks like.
So this is kind of uncharted territory because I've not done it.
Do it. New change.
Right.
Let's change it again. Make the joke better.
Let's make the joke better.
Why did the chicken cross the road? Because he was scared.
Bin, update cache, right tree.
Yep. You get a SHA.
Right.
Now commit tree. And this is essentially what git commit does, right?
Yeah,
and it still to this day does this same workflow.
And we need one more with a P.
Better chicken joke.
All right.
Love you, Kiril. So cat file that, and then we're done.
Yes.
Meow.
And then it has a parent.
Look, it has a tree, it has a parent. We've made two commits now.
Made two commits.
With the first version of Git.
There is one more thing. Two of the commands actually work on a modern day Git repository.
Yeah, let's do it.
Yeah. So
I'm excited about this.
Yes.
What of these works if we go into Git Butler?
Yeah, so the cat file and the read tree are gonna work. Okay, so I have a Git Butler modern day Git repository checked out.
Yeah.
And I've made one kind of modification, as in I've copied over the .git folder into dir cache because this too expects dir cache. So git status. So
wait, are they? It's still 2-letter.
Actually, I didn't want to kind of break it on you too soon, but it's still 2-letter now. So if
that was my fault.
Yeah. So you've been spreading misinformation.
Don't buy my book. I don't know anything I'm talking
Dir
about.
cache. Okay. Yeah.
Yep. Okay. Fair enough.
Okay, but okay. So let's see. Git log. I'll just take this commit. And I'll try to use the bin cat file onto this guy. So you see, it works. And if I cut this guy, I have
It works.
It works.
The first fucking commit 20 years later still works.
And I can grab
that is.
I can grab the tree and I can do the ls tree kind of operation or the equivalent of
that's. I mean,
bin.
That's ridiculous.
Yeah.
The index format must have changed.
Yeah, exactly. I tried. I really tried. I tried before recording this.
Read tree works.
Yeah.
Oh my god!
And I can take a blob and I can read the blob with the cat file.
Wow.
Let's get the dad jokes from over here.
No, that is highly surprising. It's actually weird to me that read tree changed very fundamentally in what it does. Like it is now ls tree and not read tree.
Right.
There is a read tree that does something very different, but like, okay, cat it. I want to see the dad jokes from.
Oh, it's a blob. Well, you can see
cat it. Cat it.
Yeah, I did. I need to hold your horses, Scott.
I have hold my horses as long as I can.
We have catted, but we need to cat again.
Hold your cats.
Right.
That's great.
It
Look
works.
at that.
Read blobs.
That still works. That is amazing. Thank you. You have taught me so much about early Git days.
I'm just fascinated.
What software do you know that was started 20 years ago is still running and still interoperates with stuff that happens today, right?
Yeah.
Like that is next level backwards compatibility. Yeah. It always works. It works from commit 1 to today, 20 years later.
Choices that you make in software stick with you forever.
They do. Thank you for showing us the first day of Git. Thank you to Linus and to Junio for creating this and for making it interoperable for 20 years. Subscribe. This is the thing.
Scott.
What?
You gotta wrap it up.
No!
We don't want to wrap it up.